Hi everyone, welcome to Lessons from Production, the show where we dive into how real systems are built, scaled, and kept running in the wild. Today we're exploring the world of logistics and distributed databases through the lens of ElasticRun, a company that's rethinking last mile delivery across India. As their platform scaled, so did their data needs, and that led them to adopt TiDB, an open sourced, distributed SQL database built for performance and flexibility. Joining us are Nikhil Sharma, VP of Technology and Architecture at ElasticRun, who's going to share how they approached data infrastructure at scale, and Bhanu Jamwal, Head of India Business at TiDB, with insights into building production-grade distributed systems. We'll talk about scale, speed, trade-offs, and what it actually looks like to run open-source databases in production. Let's get started with some introductions. Bhanu, over to you.
So yes, hi all. My name is Bhanu. I head the India business for PingCap. I've been associated with the TiDB for last almost 4 years, but have dedicated my complete career of 20 plus years to the field of data, where I've kind of participated in different sectors of data management solutions like data warehousing to big data to fast data to AI related data. It kind of covers the complete spectrum. So right now, I think I am in the most fascinating stage of data management, which is handling uh, huge influx of data which is being generated in today's era. Uh, and quite excited today to be talking about some of the data management processes.
Hi, I am Nikhil. I'm based out of Pune. I am working as a VP Technology and Architecture for ElasticRun. ElasticRun is an 8-9 year old startup in the logistics and supply chain space. In my role and capacity, I take care of the entire tech backbone that drives the ElasticRun operations. Um, and personally, I am more inclined towards an open source suite of technologies. I am more of a tinkerer. We played with a lot of polyglot stack here at ElasticRun also, and I've been um, excited and humbled on multiple occasions as part of my last 8 to 9 years journey in building multiple solutions, scaling them. So both 0 to 1, 1 to 100 journeys, and kind of witnessing the choices that we make, the tech debt that we accumulate, and how do we refactor, how do we come around. So basically, make, break, remake kind of a journey, which excites me in choosing and building the solutions.
So, Nikhil, you've mentioned that you prefer open source solutions over proprietary ones. And that's interesting, especially at scale, because open source comes with flexibility, community driven innovation, and the ability to customize deeply. But it also means taking more ownership of operations, performance tuning, and sometimes even contributing upstream. What are the biggest advantages you've seen from choosing open source infrastructure in production? And are there any specific wins that made you feel confident about that choice?
Yeah, I mean, personally speaking, I am a bit opinionated and inclined always towards open source. Multiple reasons. One, definitely the freedom, um, uh, the ability and the freedom to get under the hood, get your hands dirty, twist, tweak, run fast, look at the community. The community support is very, very interesting depending on what kind of packages you are exploring versus the commercial packaged. I don't think one is a lesser evil versus the other. I am not from that school of thought, but it's more of a personal preference. Being a tinkerer, always want to understand to the nth level of detail how things work under the hood so that I can exploit it to the fullest. And I think that's what keeps pulling me. And also, it also gives you an opportunity to augment and supplement some of the submissions and improvise it as you ride along and contribute in some means, even though very little in most of the occasions, but still that is also a very exciting part when it comes to open source versus proprietary.
Thanks for sharing, Nikhil. Bhanu, would you like to add any thoughts to that?
Yeah, I mean, I would just add definitely one point from Nikhil, that one is that there is a lot more creativity when we talk about open source projects, right? The mindset of building an architecture or a solution is not just limited to a certain group of people, but it is an idea which can be which can be explored from community at large, right? So I think definitely that brings a lot of advantage to such solutions. Also, I would say for organizations, these days, they would make these decisions of moving, let's say, from one cloud to another. For example, somebody wants to move out of AWS to GCP, or it could be the other way, right? For such organizations, if it is more proprietary kind of solutions, it kind of locks them in, and then it becomes a nightmare for them to move out of their solutions. Whether these are database solutions, whether these are some other tools which they're using from a specific, let's say, cloud provider in that case. So moving out of them or switching between these cloud providers or cloud vendors becomes a hassle, right? It becomes a big problem. So, but having an open source gives them more flexibility to take decisions, regardless of the underlying platform which they're using, which gives them, as I said, more flexibility in making such decisions.
So before we dive into the tech part, I want to zoom out a little bit. I've always been a big advocate against vendor lock-in, especially at scale. It can really limit your flexibility and drive up the long-term costs. That's why I find open source adoption so compelling, especially for companies operating at serious scale. ElasticRun is clearly one of those. You're solving complex problems in last mile logistics, working across a distributed network, and I imagine that brings a unique set of challenges when it comes to infrastructure and data. Can you give us a quick overview of ElasticRun's business model and how it operates under the hood? And at a high level, what kind of scale are we talking about, whether that's number of endpoints, data volume, or transactions per day?
So yeah, let me quickly brief about ElasticRun. As I mentioned, we are an 8-year-old startup in the logistics supply chain space. One way to look at ElasticRun is we are the B2B e-commerce engine, and we are pioneering a multi-layered fulfillment network infrastructure to boost consumption, especially targeted towards rural India, right? Outside in, if you want to look at it, we have three key verticals. One is purely B2B e-commerce, which is targeted towards rural landscape, the deep hinterlands of India. Second is a managed logistics, which cover both urban and rural territories equally well. And third is a new kid on the block, where we are opening up a lot of our tech stack as SaaS offerings. Because our proprietary technology we have baked, battle tested over a number of years, and they are now also well sought after by many of the similar players in the logistic industry. Now, to talk about some numbers, as part of our operations, we are present across all 28 states. We cater to more than 1.5 lakh kirana stores when it comes to the rural landscape in India. Our foot workforce or the field staff basically traverse millions of kilometers across the different rural landscape. We touch basically 40,000 villages in India, spread across 12 states, catering to 1.5 lakh kirana stores in terms of taking an order from them and catering the FMCG and commodity items to them on the next day. So that is one very intense and very well received business vertical at ElasticRun. In addition to that, we are the largest service delivery providers, operationally speaking, to all the large marketplaces, all top 3 marketplaces in India. So these are some of the operational footprints. In doing that, we basically work with a workforce, a gig workforce of almost 50,000 people logging in into ElasticRun network, taking a piece of work and completing it on a weekly basis. We process almost more than 100 million checkpoints daily. When I say checkpoints, think of it this way, that a shipment is getting handled and delivered. Any operation that happens to it, any touch, any sorting, putting into a bag, delivering it to a customer, returning it, everything gets checked as a checkpoint. So more than 100 million checkpoints get handled and processed daily. For this workforce, we calculate, basically we assimilate a lot of data points in the form of attendance, distance traveled, shipments handled, checkpoints played, orders placed, deliveries made, cash collected, and based on that incentives are calculated. So we have a suite of tech backbone which consists of right from crowd sourcing these personas or profiles, doing a background validation check, processing their incentives, making a task allocation. Almost 5 million tasks are assigned to this 50,000 workforce throughout the day. right, and which gets completed. So these are very micro granular tasks. Their completion is recorded, incentives are calculated, and at the week, based on the frequency of payment, weekly or monthly, a lot of payouts are made to them. So that's in nutshell the business of ElasticRun and how technology plays a role to manage and tame this at scale. Because working with gig workforce is hugely complex as opposed to a captive workforce. So that's where tech sits right at the center of what we do and how we do it.
Thanks for sharing that, Nikhil. It's always great to hear how things work when they're going right. But I'd love to shift gears and talk about the challenges. Because at this kind of scale, things do get interesting. When you're running a large scale operation like ElasticRun, there's always a point where the cracks start to show. Were there any early warning signs, performance issues, bottlenecks, or anything that looking back you wish you had acted on sooner? Also, we often hear that distributed databases scale horizontally, just add more nodes and you're good. But in reality, that's always, there's always a tipping point. In your experience, where do distributed databases usually hit diminishing returns? And how do you optimize beyond just throwing more hardware at the problem?
So talking about the challenges that we face while building and scaling solutions for ElasticRun, and I think many of the people, especially in the startup world, will be able to relate, that as a team we huddle, we come up with an idea, we try to come up with a minimum viable product or even a lesser version of it, and start in a very agile fashion. When I say agile, I mean consider it on the abusive side of agile. I mean, just take a call, get into Ninja Action Force, 3-4 developers, build something up, run it, throw it up there. Because at the same time, we have to also do a business validation, whether there is a unit economics is making sense, whether there is a viability in the market, and especially we being in the operational space, we are a full stack provider to many of the marketplaces when it comes to fulfillment, delivery, and distribution of items and products. And we do a tons of pilot. So the most interesting challenge that we as a team have always faced is we start small, we throw something. If it catches on, you have absolutely no leg room or breathing space to come back and fix things. So which means a lot of choices have to be made upfront in the sense that they will lend you towards a certain scale, right? And then there is a non-stop functional feature list that we have to cater to for our own users and business. So both from an extensibility of the solutions or the platform that we are building, as well as the volume wise scale. And that is where I think one of our most recent experiences come into the picture, where we build this um, very practical, pragmatic shipment handling platform. We call it by the name Libera, which basically sits right at the center of how we deal, handle, and deliver e-commerce shipments to the last mile doorstep delivery of the Indian consumers. And we deal with millions of shipments there and hundreds of millions of checkpoint daily. And it continued to grow, swell at a breakneck speed, which means that we had very little room for cleaning up the tech debt. And we have to continue to deliver to a lot of functional asks and features. We kept unlocking. As you rightly said, horizontal scaling is the buzzword. Looks like a magic wand, but it really isn't. So web was a no-brainer. We did our journey. We started with containerized deployment. We adopted Kubernetes, which gave us a real unlock at the web level, at the app level. But data tier continued to be a pain point for us. And we were onto a Python and a MariaDB stack, just for audience to know about what tech stack we're talking about. Then we kept applying a lot of logical incremental approaches, separating read writes, applying CQRS, containing heavy reads, separating out all the reporting analytics pieces out. But then you definitely hit a glass ceiling until unless you fundamentally go and revisit. And that's the kind of whiteboarding that we are pushed towards, that it's the tipping point. Do we need to relook and reevaluate the entire strategy? For this kind of a berserk volume, is NoSQL a better choice? A distributed database is a better choice? Or our current relational with some sort of a clustering tool set and paraphernalia will bail us out and take us to the next level? Are the different considerations that we went through. again, lot of thing we could unlock by virtue of just read write segregation and throwing lot of application tuning. But that also led us to a glass ceiling where we were throwing immense amount of metal just on the write, because in conventional sense, the relational databases having too many write peers is very very complex and very very admin heavy, and that's where we stumbled onto the distributed databases concept, and we started tinkering with the likes of Vitess and TiDB.
That's very insightful. Now I'm curious about the decision-making process here. Because when you start hitting those limits, what approach did you take to solve them? And what options were on the table, whether architectural changes, different databases, or tuning strategies? And what made some of them fall short? There's obviously no one size fits all in infrastructure. So how do you figure out what's right for your workload and what is not? Is it intuition, metrics, pain points, or a bit of all of three?
As I mentioned, we had this immensely pragmatic operating platform which was used by thousands of workforce at a station, delivery station. So just imagine in your mind um, a station, say of the size of 2000 to 5000 square feet, dealing it with 5000 or 10,000 of shipment, e-commerce shipment. Those need to be handled, scanned, sorted, bagged, assigned to delivery associates, a biker who is coming using a mobile app and delivering to a doorstep, collecting the cash and returning back. So that's the classic day in life of what this particular operating platform that I'm touching upon or bringing up here in the conversation is all about. Functional complexity wise, I would say it is on a moderate level. It is not very complex like an ERP of the sorts functionally, but it is rich in the sense that there are different personas who interact. So there is a delivery associate using a mobile app. There are a lot of sorters, station staff which are operating at the same station. Some is doing bagging, some are doing sorting, some are doing cash handling, some are doing DA assignments, dispatching the DAs, consolidating the van. So yes, it is feature rich, but it is not of that level or magnitude of a ERP kind of a system. Now while we kept building, we started nimble, we started small, and I think that's a perennial debate of monolith versus microservices. So the framework that we use inherently for most of our stack is in the Python space, and it is Frappe, which has been our conscious choice for the rapid application development, that it allowed us to churn the functional requirements at a very very fast pace. And we continue to put into that space, and we continue to scale this particular platform uh, across multiple locations for tremendous volumes. It was backed by MariaDB. So logically, how we progressed is we kept scaling the app tier, the web tier with the help of Kubernetes, the containerization, and it worked out well for us. Though we had to throw a lot of tuning at a Python level itself, because Python also inherently, we know beyond a certain point and scale for very very high throughput concurrent transactions is not the really best choice. So we did deliberate there, but we stayed put because we were able to find unlocks and refactoring at an API level. Data tier is where our biggest challenge and concern has been for a good part of this particular scale up journey with the business. MariaDB being relational, open source, we used a self-hosted version. We kept scaling, we kept tuning the queries, but the workload kept growing. And the first juncture was to basically separate out the reporting load versus the OLTP read and write loads. For that, we leaned towards MCS, which is the columnar store, MariaDB columnar store, which is easy for the reporting, so that we cut out the reporting load separate. Um, Volumes kept increasing. The next logical pit stop was basically separating out the writes and reads. So that's where we threw multiple replicas to the primary MariaDB server. Writes were only targeted toward the primary, reads were to secondary MariaDB servers. But there again, there are it's not it again always stalls after a certain level, where it forces you to relook. The kind of challenges that we faced were these replicas started falling out of or falling into the lag. So there were lags beyond 100 seconds, 500 seconds, which is again detrimental to real-time operations, because whole of shipment processing going parallelly across thousands of delivery stations and sort centers, they need real-time updates and real-time sync. So that became the choking point. We kept breaking our workloads, the commits, into smaller chunks, so that none of the big commits lead to a big lag across the replicas. Even after throwing replicas, 70% of our throughput was still getting catered to, served by the primary database, which was our primary MariaDB. The second pit stop that we took is we identified pieces out of it. We went for application federation. We identified chunks of transactions which were pointed to specific. So for example, if there is something related to logs, audit logs or message logs or versioning, those were culled out and put into a separate database plus a separate set of services altogether. So we started breaking the application. Along with it, some sort of a write break also came in. That also gave us some amount of lease and time window to continue to handle the volumes. But again, it was a makeshift arrangement, because what was needed really at that point in time was to fundamentally look at the way transactions are coming in, the way we have built in the reads and lights, and that's what pushed us towards evaluation of other solutions. Definitely caching played a big role in getting that intermittent breakthroughs and easing out the throughput and the load, or the QPS onto the primary MariaDB. But then we went to the whiteboard as a team. We debated right from Python to the SQL to NoSQL to distributed database options. And it's not easy. So if so any tech space, if for that matter, if you go, and many of the audience and viewers would be able to relate with it, tech is an opinionated space. You can have as many pros and cons for Python versus Go, or NoSQL versus SQL databases as you can. And finally, the preferences and opinions do play a significant role. We were no different. We were also a split crowd internally. We kept debating. We did a lot of pilots. But the place where we were poised at, the kind of volume, the functionality that we had built into this particular platform, breaking it down into microservices, what was a very big over engineering effort. Migrating the entire data layer to MongoDB was another rewriting of that particular effort, which definitely didn't make sense, because functionally we had a very pragmatic platform which was well received, and just changing the data persistence layer was a big cost element. And still we had to cater to the reporting, and we still had to bring that NoSQL data back into some relational sense to be able to deliver a lot of reports, because operations runs on metrics and they need a lot of data points to see what is going wrong and how different partners are performing. And that's where we came to the distributed database realm. And Vitess is what I would like to bring forth in this particular forum. Vitess was the first thing that we stumbled on. Those who don't know, Vitess came from YouTube team. So it's again an open source distributed relational data. Uh, it was created by YouTube. YouTube still runs a very large farm, almost 50,000 plus, or maybe lakhs of MySQL servers there on Vitess. So we evaluated that. That was our first hands-on exposure to distributed databases, the challenges, how to look at sharding, what complexity it brings to the table, because so far we were in the monolith realm. The moment you break it down to tiny pieces, it just gets into a crazy space. It is not at all easy. You have to tie back that data for larger reporting. You still have to make sense that the entire visibility should be at your hand. What should be your sharding strategy? And given a functionally rich application, there is no silver bullet that this is the only way that these top tables can be sharded. Every transaction, every table might have a different nuance, and one sharding strategy may not work. So we basically deliberated on those spaces for a good amount of time. We also did handful of pilots in a small environment, trying to warm up ourselves, get our hands dirty. While doing this is where we basically stumbled onto TiDB, which, based on the community forums, the articles, we felt is almost at par with Vitess. And when we started diving deep or getting under the hood of TiDB, we actually fell in love with the structure, the way the entire TiDB as a product has been created. Because we had tried our hands on Vitesse to get it up and running, it takes a lot more of effort to know and understand. TiDB came out as a very, very simplistic product, even though it is in that space of distributed databases, plus very rich and healthy documentation, and ease of setting it up and ease of making it run was far simpler, at least in our experience, as compared to Vitesse. The more we read the documentation, the more we read about the layering in details that TIKV holds the store, TiDB is the engine layer, and the role that PD plays. We kind of liked the entire ensemble. Plus, to top it up, there is TI Flash, which basically eases out your entire reporting um, load without the hackles of getting a lot of data engineering pipelines into the mix. So we did our first pilot and run through, and I think after that it was unanimous. The entire cohort, the crack team, coming from engineering, cloud, reliability, data team at our end, they were unanimous in a week's time that yes, TiDB is the choice for us to go ahead and let's take it full on. And that's where we basically went into a breakneck speed of 6 weeks to go live. So I will pause here and I will take that 6 weeks to go live maybe in a second spurt, Kunal.
You mentioned you eventually landed on TiDB, and that's great. Bhanu, I want to bring you in here. As someone from TiDB, you've probably seen a wide range of use cases. What kind of sectors or industries do you typically work with? And where does TiDB tend to shine the most? Is it mostly data-heavy platforms like ElasticRun, or have you seen some surprising adoption stories as well?
I want to pick one point from what Nikhil just mentioned, that when you have to rethink about your architecture, you have to fundamentally change your mindset, right? And I think talking about distributed databases is a change in mindset. If you come with the same mindset of running on a traditional database, it will be very hard for you to even understand the concepts, right? So I think the change in mindset is utmost paramount to understand how a distributed databases make such a difference. And to your question on what are some of the industries which get benefited from distributed databases like TiDB? I would say any digital native businesses as of today, specifically in India, right? We have seen growth. We have seen companies who've become unicorn in matter of years, right? Which was unheard of if you talk about 10 years ago. And ElasticRun is a typical example. I'm personally uh, so intrigued with the business model of ElasticRun, where they're tapping on rural sectors, which not many other e-commerce businesses were doing. So I think that's one typical example of digital native business. But other than e-commerce, right, we are talking about quick commerce today. We're talking about fintechs. We're talking about logistics, SaaS companies, which are coming in abundance today in the Indian market, right? And also we talk about Web3. Web3 already has about 1,000+ startups in India, and they are growing, even though the regulation is not yet there. But imagine the day when there is more clarity in regulation, Web3 would just explode, right? And then we are talking about gaming industries. And one thing which is common in all these industries is the amount of data growth which is happening. The growth of organization is, of course, very, very rapid. But at the same time, they are generating that much amount of data uh, in a similar pace as they're growing. And because of that, traditional databases like MySQL or Postgres or others of the likes are falling behind because they are originally not designed for such growing workloads, right? And I keep hearing from some of the founders of these amazing digital native businesses that this is just the initial phase of this ever growing market. So imagine if this is called the initial stages, then down the line in 2030 or 2035, we are looking at 10x to 20x of growth which is happening in these organizations, which means the amount of data which is going to uh, be uh, be be grown or develop would be a lot more than we can't even imagine, right? And I think that's where distributed databases come in. This is the perfect time to start thinking about distributed databases to cater to your ever increasing workloads, uh, to your ever increasing data volume for one, but in addition, how effectively can you grow your incoming traffic? Running your queries a second, getting the lowest latency possible, are all becoming need of the hours. I think this is becoming a necessity rather than an option which was probably there 5 years, 10 years down the line.
I love that answer, and you touched on something really important. You said databases aren't just a technical decision, they have a real business impact. For a lot of companies, especially those still growing or waiting for that right moment to invest in infrastructure, it's not always obvious when to make the move. Can you share a moment where fixing a database or infrastructure issue had a direct, visible impact on business? Maybe something that improved delivery times, reduced costs, or just made the lives of your ops teams a lot easier. What I'm trying to understand is like, is there a specific KPI or that aha moment where people are like, okay, now is the time where we need to, invest in this?
I think I remember I was asked this question in one of the events where I was speaking, and I had an answer where if, as of today, you are doing any workarounds uh, for your existing database solution to cope up with your growth of data, I think it is already time for you to start thinking. Because if you're thinking about workarounds, or sometimes we call it as patchworks, then very, very soon you will hit that bottleneck if there is, all of a sudden more influx of data coming in or more influx of workload coming in, right? So if you are already in that stage, and by workarounds, I can give a very simplistic example. So if you're today on a traditional database like MySQL, and you are in the need of doing data sharding, where you're sharding your data on different MySQL databases, and the only reason you would shard today is because you can't just hold that one data set in one single MySQL database because your SQL database is going slow, is one typical example of workarounds. And if you're already doing that, I think then it's time to move. And I would try to call out on what are the top key challenges which we come across, which the businesses have been facing these days. The first one is when they get into this entire sharding concept, where they are moving data to different individual silo MySQL databases and then managing it as a cluster. Whether you're using it as by the way of using, let's say, Vitess as a solution, or you're doing it manually, right? It becomes complex. The second one is if since your data is increasing, you need to scale, right? There has to be a way to scale. And if your traditional databases don't allow that, right? You can't really scale. And then specifically, if I talk about from e-commerce, quick commerce, or logistics standpoint, you are talking about this ever increasing data volume, whether it is tracking shipments or it is inventory management for you. Your data is growing because these companies have access to direct end users through their mobile app, right? And I would call out one more key challenge, which is the capability for you to have real-time insights into what is really happening into your into your system, right? Again, taking an example of logistics, for example. Uh, if you have real-time visibility in terms of your supply chain management, how do you make it more efficient, right? How do you find out whether you have updates on delivery routes? What are your status of your vehicles, or what is the driver performance, and so on and so forth, right? All this information, if you get it in real time, you can actually make decisions in real time, right? And you can make appropriate changes and kind of make your entire process more efficient. So all in all, these are probably the key challenges I talk about, which are at the core, which we keep listening everywhere. And I think I think I can talk about TiDB is one distributed database which kind of solve these problems, right? And I can take a pause, but I can explain more on how we really do it. But I think TiDB is in that sort of scenarios where it is solving these key challenges.
Thanks for that. Nikhil, I want to come back to you. Open source solutions definitely offer a lot of flexibility like we spoke about, but they also require strong ownership, especially when it comes to implementation, tuning, and long-term maintenance. What were some of the key considerations you had when adopting TiDB's open source version for your architecture? Were there any specific things you had to plan for, like team readiness, tooling, or integration with existing systems?
Yep. So yeah, I think adopting, implementing any package or product into your landscape is really a critical decision for any landscape, be it open source or be it a commercial or a proprietary package. Right fitment is extremely important. Uh, I think in my experience, or maybe in my preferences, open source always takes preference because of the multiple reasons that we discussed earlier in the first part of this particular podcast. The freedom, the community support, the ability to get under the hood, understand it in and out, um, reading the documentation, ability to customize it in case or extend it in case there is a logic or there is a sense for the same, are some of the pieces where we lean ourselves more, at least as a team at ElasticRun, more towards open source as compared to proprietary. In terms of the implementation, my reflections are basically more of tinkering, more of hands-on, be iterative, fail fast approach, have a very good read of the documentation. Um, in case so documentation is a must. In fact, having a swim down the code base, because in the open source that is the best tool that is available to you, is you can just deep dive into the code also when needed. But documentation is a must. Community articles, community videos are the must for you to ramp up yourself to the different nuances of this particular product and how different people have adopted and implemented it, and what are the challenges that they faced, how they overcome those challenges, so that you reduce your unknown surface when you are getting into an implementation zone. Once you set your sights on, when you have done enough tinkering hands on, I think creating and forming a crack team is of critical importance, depending on to the nature. For our case, putting in TiDB at the data persistence layer, we created a very cohesive crack team, multidisciplinary crack team of consisting of cloud engineers, reliability, QA, data, core engineering team from the product itself, a very small niche cohesive team of 7 to 8 people who worked completely dedicatedly on this particular transition, so that we vet out all the scenarios. It involves regression testing, it involves data ingestion, how data is getting ingested, how it is getting stored, doing multiple workloads, performance testing, reassessing different parameters, understanding how TiDB as a product works. We also did a lot of chaos testing, pulling off the nodes, shutting down the VMs, so that we are very well versed what worse could happen. Because once, as Bhanu rightly said, it's a paradigm shift. We are very used to for years dealing with a monolith database, RDBMS, and the entire data is at one place. The moment you break it down into say 20,000 shards or 1 lakh plus shards, it's like your entire thing is broken down, and that's where it can be very overwhelming for the team to be able to stitch it back, because we are very used to knowing, yes, data is at one place. In this case, it gets spread out, and then you may also have to relook at refactoring some of the code, the way you have coded, the way you anticipate most of the data or set of joins coming from a single source, but it will now be spread out to maybe 10 nodes or 30 nodes of TIKV. So all of those ramp up is needed in terms of doing more and more hands-on, more and more workloads, and more test cases to be vetted out. For the final rollout, I think it will depend. We were on a very breakneck speed in our transition to TiDB, and hence we valued time over cost. And the way we went about it is we launched 3 massive cluster. We were over provisioned. We didn't worry too much about the spec. Whatever spec came in, we just went ahead with double the capacity, because we wanted to make it land and make it work, rather than getting stuck into minor capacity issues, where capacity is basically throwing some kind of a housekeeping or a balancing between the different nodes and slowing down the things. So that's how we went about it. We created 3 different clusters. There were contingency and phased stages identified. That first stage was just to mirror, after doing all the thorough functional regression, performance load test, we actually mirrored the entire production load on one of the clusters. We seeded it with 3 weeks of data. We mirrored the entire production load through our own custom handlers. We vetted it out that how it is going to perform, if any tuning is needed. Second phase, and then we threw that entire cluster away. By that time, the second cluster was ready with the seed of data. It was used to funnel all the actual read which is happening in production, and then that lived its life for 1.5 to 2 weeks. And then came the third DB cluster, TiDB cluster, which was completely in sync with the production database, because that also gave us seeding time of the data. And that's where we basically switched on both the read and write. So that approach is also very important. This is what made sense. Just to give you an analogy, it was like launching a rocket ship with additional boosters, and each booster coming off having served its purpose until the final cluster became the primary cluster for us. So that was the rollout strategy or the transition strategy that we adopted with TiDB, and it worked well with us in terms of being open that yes, we do have to seed data multiple times, we do have to have the iteration, and we were mentally prepared that by doing this different incremental phases, some of the data may go corrupt, although that didn't happen. But we were mentally prepared in terms of the different backups of clusters and multiple loads of data. In nutshell, we basically migrated more than 60 terabytes of data in a span of 4 to 5 weeks across these different clusters.
Bhanu, I want to come back to you for a second. You're on the provider side with TiDB, and we're hearing some great feedback from Nikhil about the experience. That says a lot, especially in the open source world where support and community can really make or break adoption. So from your perspective, what do you think TiDB is doing right as a provider? What are some of the best practices you follow when working with customers? And why do you think TiDB has gained so much popularity in the open source database space?
So, Kunal, thanks once again for having that question. So probably I'll start with our open source, and I'll give you a very quick story. The founders of PingCap were originally the very hardcore MySQL developers, and they were experiencing this challenges of data growth and manual sharding, and managing all this was a nightmare to them, right? This is what urged them to build a database from scratch, and more importantly, keep it open source, right? This was their fundamental approach towards building a database, that they want to keep it open source. They want to make this particular database reach out to the community as big as possible. And as of today, if we kind of see on GitHub from any open source projects as of today, you would find that generally, we rank the popularity of a particular solution based on the number of stars you receive from the open source community. And if you compare databases in the GitHub space, TiDB is one of the very top in terms of receiving the most number of stars from a community across the globe. Right. So our focus is gonna continue on open source. And while we do that, we are also investing heavily in India, in other parts of the globe, to keep our community engaged with us. Whether it is in form of doing hackathons or inviting them to participate in some quarterly or half-yearly challenges, right? And give them the access. We have something called PingCap University, where we can give them access to come and learn about distributed databases, right? And have a different mindset of how distributed databases work as opposed to our traditional databases. So that is more about the open source. But I wanted to touch base upon some 3 or 4 different use cases where I wanted to highlight what is it different which we're doing in the market, compared to any other distributed database as of today. So I'll pick the example of LinkedIn. So LinkedIn core evaluation strategy to choose a distributed database was consistency at the core, and resiliency, which is high availability as well, right? And they evaluated 5 to 6 different distributed databases, and finally narrowed down and selected TiDB because of it is highly consistent data at all times. I talk about Pinterest, which gave us a challenge that they wanted to store 1 petabyte of data volume on one single TiDB cluster, right? And it is very unheard of having such a big scale of data residing on an OLTP database. So we gave them that solution, and today they are holding over a petabyte of data on TiDB. When I talk about Atlassian, Atlassian's requirement to us was because they are a SaaS company, and every SaaS company, for every tenant they hold, needs to store more and more metadata, more and more database objects. So the number of tenants is the number of schemas you will be holding on a database. Their initial requirement was to hold 1 million metadata objects on one single database, right? And honestly, I don't think so. There's any DB which can hold that much data but at the same time giving seamless performance. During the evaluation, we gave them about 2.5 million metadata objects which could be stored. And they have now a new and even more aggressive requirement, which could go even beyond 10 million or probably 50 million objects. Right? I think to conclude, what we as TiDB say is scalability is not just about data volume increase, right? Because every time we go and talk to our users and customers and we say, what do you think scalability is? A common answer from a community is increased data volume. But then we did this survey and we went to all our customers and we asked them, what does scalability means to each one of them? And the response we got was, of course, data volume, that my volume is increasing. Today it's 1 terabyte, sorry, and it goes up to 10 terabytes, or it can go up to 100 terabytes. And as I said, at last, Pinterest, which has touched 1 petabyte, is definitely one classic example of scalability. But there is beyond that. We got to hear from Atlassian that for them, scalability means storing more and more metadata objects, right? And today they are storing about 2 million plus metadata objects on TiDB. Right? We talked about we got another flavor from a customer called Databricks. So Databricks uses TiDB heavily, and their metadata control plane runs completely on TiDB. And for them, it was how can I consolidate my different siloed MySQL databases onto one cluster, put everything into one cluster, and then seamlessly run it without creating a noisy neighbor issues, right? Or we heard from certain customers on how effectively can I do batch workloads, because we also support analytics, right? And obviously, when it finally comes down to, at the architecture level, we are talking about HTAP, which is your hybrid platform, which can do both your transactional processing as well as analytical processing on one single database, which is another edge which we have over our competitors, because we can do high scale OLTP systems. We have a customer who runs about 1 million queries a second. Does a read of 1 million queries a second. And at the same time, he can just go ahead and do a nasty analytical query on the same database, which would not create any impact on the transactions as said, right? So it's a true edge trap system. So I think all in all, this is where we are, and we have very aggressive plans to not just stop here, but we want to see the future 10 years from now. So we are working on, and we are reimagining TiDB, right? So maybe very, very soon you will hear about another new next generation architecture, which would leverage S3 as a data storage in going forward. That will be in future, of course, right? So the innovation continues, and TiDB continues to grow.
Amazing. Thank you, Bhanu. Now, looking at it from a guidance point of view, there are so many companies out there thinking about making the leap to distributed SQL, but it's a big shift. If you had to advise a company adopting distributed SQL for the first time, what's the one thing you wish someone had told you earlier, or something you consistently see teams overlook?
Yeah, so I think my piece of advice to anybody who wants to move to a distributed database would be that, one, that there would be a certain learning curve. from your traditional databases to your distributed databases. But I think the moment you understand that that shift from a mindset from traditional databases to a distributed databases, I think your journey you would have a good experience in your journey.
Amazing. Well, thanks for sharing, Bhanu. Had a really great conversation with you and Nikhil. Nikhil, looking back with everything you've learned from scaling ElasticRun's infrastructure, if you were starting over today, what's the one thing you would do differently when designing your data architecture? Whether it's a technical decision, a process, or even something cultural, what stands out in hindsight?
Very interesting question, Kunal. In fact, if you would have posed that question to me, say 2 months ago, my answer would have been very different. Because in our landscape, we have dealt with everything. We have traces of PostgreSQL, MariaDB, MongoDB, MCS. We also have our data warehouse now on Databricks. So we have, at least our data team has had all the shades and all the flavors. And also to connect to your previous question to Bhanu on distributed SQL, what is the paradigm shift and what people should be ready for? My personal experience and journey in last 2.5 to 3 months while adopting and migrating one of our largest operating platforms to TiDB, a distributed SQL database, is that gap has been bridged significantly. So right now, actively, and I'm not exaggerating, we are looking at TiDB becoming the entire data fabric, because that's the seamlessness that it brings. 3 months ago, if you would have taken my opinion on warming up to distributed SQLs, I would have been very, very conscious and cautious to the audience that it's a paradigm shift. Your data will get broken. You have to have different strategies in place. How will you make sense? How will you troubleshoot? I think most of it has been splendidly handled and packaged as part of TiDB, and that is what my journey is. So today, starting today, in fact, one of the casual conversations that we were doing after our go live was, had we stumbled onto TiDB earlier in our journey, we would have been at a different place today, and all our landscape would have had 80% plus of TiDB footprint. So yes, I think TiDB sits right there, and we are consciously evaluating it, rather than entire distributed database landscape, as a data fabric seamlessly, because TiDB just makes it simpler, both from an installation, adoption, observability. The amount of observability it opened up, it also helped us catch up on a lot of tech debt and optimization within the application code itself. So the benefit just didn't end up at a data layer. It bubbled up and we benefited a lot at an application tier level, which was otherwise a bit obscure, or rather too immersed into the realms of multi throughput or high concurrency processing, and we were not able to detect those out. But TiDB brought it all up with its observability, immense observability, and one should actually do their hands dirty and check it out.